Hello students, today we will be converting between sequences, section 11.6. Now our objective at the top, it says I can write formulas for sequences. So we will be converting from recursive to explicit formulas and then from explicit to recursive formulas. So first of all, at the top of the page, 158 for regular and page 170 for honors, it says they have a recursive formula up there at the top. A1 equals -4, and AN equals A to the n minus 1 plus 3. What does -4 represent? A1, which is the first term in the sequence. So we write that down. First term in the sequence. Okay, and then since it has a plus 3, what does the 3 represent? And that is, since it's an arithmetic sequence, it's the common difference, or D. Okay, so again, that is part of that question up there at the top. Okay, now we are going to go from recursive to explicit formula. Number 1 says A1 is 20, A to the n equals A to the n minus 1 plus 7. So when we write our explicit formula, we get A to the n equals 20 plus 7 times n minus 1. Now we could go through all the trouble of simplifying and everything, or we could actually find A to the 0, which means I would take the 20 and I would add 7 and say A to the 0 equals 27. And if you did all that, and actually it's not 27, I have to go backwards. So instead of adding 7, I subtract 7 from 20. So that A to the 0 is 13. Okay, so then when I write the formula out, I get A to the n equals 13 plus 7n. And that is our final answer. A to the n equals 13 plus 7n. So I know it's a little bit messy and scrunched in there, but there you go. Okay, now I'm going to jump to number 4 and do it in function notation here. Again, I'm converting from recursive to explicit formula. So we know f of 1 equals 1/4, f of n equals f of n minus 1 plus 1/2. So instead of adding a half, we can subtract a half to get f sub 0. So if we subtract a half, we get -1/4. Okay. So then when we write it out, we can say f of n equals -1/4 plus 1/2 n. Okay, so again, this number that's added here and the number that's added here will be what goes with the n, because it is our common difference. And then this f sub 0 goes here, a sub 0 goes there. And that's how you do that. Now we're going to go from explicit to recursive. Okay, so number 5, we're given the explicit formula, -26 minus 7n. Because remember, this first one now is a sub 0. So to get a sub 1, we're going to combine these two, but pretend there's not an n. So we have to take this, and we're going to add a -7. So we know that a1 equals -33. Okay. So then we write out our equation, and we get a to the n equals a to the n minus 1 minus 7. And you're done. Okay, so now we're going to do one in function notation. Again, this is the explicit form. And we're going to first find f of 1. Okay, this right here is f of 0. So we have to subtract 1.2 from that. So f of 1 equals 3.2. So our formula f of n equals f of n minus 1 minus 1.2. So you need both parts here for the recursive formula. Okay, so, and again, you'll need both parts here for the recursive formula. Okay, now we're going to do a couple more problems. And we're moving on to the next page. Page 159, regular, 170, honors. We're doing number 11. And it says A1 is negative 256, AN equals A to the n minus 1 times 1/4. And we're going from recursive to explicit. So we say A to the n equals, and again, we put our A1 first, negative 256 times 1/4 to the n minus 1. Okay, again, this is a geometric sequence. And the others were are arithmetic sequences. And up at the top, it does say, I'm going to back up here for a minute, A1 is 2, A to the n equals A to the n minus 1 minus 3. What does 2 represent? And it is the first term in this sequence. So you should all be writing this down. Okay. What does negative 3 represent? That is R, or the common ratio. It's what everything is being multiplied by, okay? All right, so then we can go on to 11, where we have this recursive formula. We change it to the explicit formula like that. Okay, then we're going to jump to number 14, or actually we could go over here and look at this formula. What does the 2 represent? And again, number 2 is the first term in the sequence. What does negative 3 represent? R, or the common ratio. Okay, now number 14, A to the n equals negative on the outside, and then 2 raised to the power of n minus 1. So this is the explicit formula, and we have to write the recursive formula. So the first thing we need to figure out is what is A sub 1. Now up here, actually I guess we don't have other one like this. It's a little bit different. See, with the recursive you have to name A1. So here is A1, so here is A1. But you're like, what does that negative mean? It means whatever you figure out what this is, then multiply it by negative, because exponents come first. So I'm going to put a 1, make that a negative 1 times all that. So A1 is actually equal to negative 1. Okay. Then we write our recursive formula, A to the n equals A to the n minus 1 times 2. and we're done. Okay? I think you can do both pages pretty easily and get prepared for the quiz coming up. You can do it, students. You rock.